All right. Good afternoon, ladies and gentlemen. Thank you for attending here at the first inaugural UCR Patent Award Ceremony and celebration of the one-year anniversary of the Entrepreneurial Proof of Concept and Innovation Center, or EPIC, as we like to call it. My name is Brian Suh. I am the Director of the Technology Commercialization within the Office of Technology Partnerships in Research and Economic Development. We're going to get started here. So it is my honor to introduce you to Michael Pisani, who is the Vice Chancellor for Research and Economic Development, to kick things off at this inaugural event this afternoon. Mike, thank you very much.
Thanks, Brian. There's a number of people I actually want to thank. First of all, the County of Riverside has been a great supporter of the university, Rob Field in particular. And I actually want to thank someone who always sits in the second and third row, but has been instrumental. Rosabelle Ochoa came here more than a year and a bit ago and has really put a lot more energy into our entrepreneurship programs. So here we're here to celebrate two things. One is a patent award ceremony, so we're here to recognize the faculty who have made discoveries that are novel, that are useful, and that are going to provide some benefit to the world and the industry. And second, we're here to honor the one-year anniversary of EPIC, our Entrepreneurial Proof of Concept Center. Now, what is a patent anyway? From a patent, what you can really do is you can prevent anyone from practicing your invention. Isn't that a great thing? So why does the university do that? Why do we want this property right? It's not to prevent people from doing it, but so that we can choose our partners, so that we can develop partners with people who are willing to invest in the company, who have the mechanism to take our products into market. Because while we do the early stage invention, it's really important that we have an ecosystem in which takes our inventions and makes products, sells them with it. And so that's why we're also here to celebrate the new center that's been around for about a year, funded by the Economic Development Agency and funded by the National Science Foundation as an I-Core center, recognizing that we are a center of excellence in this area. And then I also, now my job to introduce the next speaker who will introduce our keynote speaker. The next speaker, Catherine Urich, is an inventor herself. 10 years ago, she might have heard a similar speech at another university that I gave, where she actually helped to hire me at that university. And then I guess I helped return the favor by bringing her here. Catherine is a polymer chemist and is an inventor and has many patents and is involved in the startup process. And I think she's bringing a lot of energy and ideas into the academic part of the campus about how we could be more entrepreneurial, and that's important. So Catherine, come on up and let's introduce our speaker.
Thank you. It is really a great honor and a pleasure to introduce Dr. Tina Nova. Tina is currently the president and CEO of Molecular Stethoscope. It's a San Diego-based molecular diagnostic company. The company focuses on circulating cell-free RNA from blood as a biomarker for the assessment of specific organ health and disease. So this is, I say generally, Tina is what I would refer to as a serial entrepreneur. So she was also senior vice president at Illumina, who ran the oncology business unit. She was a CEO of Genoptics Medical Laboratory. Was also involved in other startups, Nanogen, Ligand Pharmaceutics, and Hybridtech, and many, and now sits on the board of many different entities. Well, it's wonderful. I could spend a lot of time talking about the scientific thing, but scientific accomplishments and achievements. But I do want to spend just a few minutes just highlighting who Tina is. Amazing scientist, but also just an amazing person. She, like many of the students, 60% of the students at UCR, is a first-generation college student. She works really hard to make sure that as many people are involved in science and technology as many. So she spends a lot of time advocating for STEM, spends a lot of time advocating for women, and had recently received from the Athena Foundation, which focuses on promoting women in STEM, the Chairman's Award for Lifetime Achievement. That's a pretty amazing accomplishment, as well as featured as one of the top 10 women in biotech. So, and all of these kind of entities are recognizing her for her entrepreneurial activities. But again, I welcome Tina here, really as an entrepreneur, as an amazing scientist, and as an amazing promoter of women in science. So Tina, please.
You always sound so much better when someone else introduces you. I also sound like a woman who can't hold a job. She was here, she was there. All it really means is you're old. Thank you, Catherine and Brian and Michael, for inviting me to come here today. It was wonderful. I came in this morning, got out of my car and said, oh, I forgot that heat. How nice to be back into Riverside. And then I got to go up and see the lab bench, the spot where I worked for many, many, many hours. And it was incredible to walk back in the lab and to be there. And it was a very nostalgic day for me. And to meet so many incredible people and so many young women and men scientists, and to see the changes that have happened at UCR. It's just really amazing. I've made a lot of good and bad decisions in my life, there's no question about that, but choosing to come to UCR, there's no question, was certainly one of the best decisions I ever made, and I truly mean that. And that's really where I learned to be a scientist. I learned what an experiment was. I learned how to design experiments, to develop critical scientific thinking, and really to understand the ethics of science. And I have UC Riverside to thank for that, and Dr. Jolinda Tra, who was my mentor for so many years. So I feel very fortunate in my career. I don't feel like I've necessarily been successful. What I feel like is I've been able to do what I love for a long time. And there's nothing better when it comes to your career than doing something that you really, really love. And that's the way I feel about my job and position and career. And I think it's great that you guys are really focusing on inventorship. And actually, that's something that isn't done that much. I've never seen an award ceremony for inventors before. And so I really, I'm really think that you guys should be proud of the fact that UCR is so progressive that you really think about doing something like this, because inventors really deserve to be recognized. And if it wasn't for inventions, we wouldn't have the biotech industry that we have. We wouldn't have the pharmaceutical company we have. We wouldn't have the device company that we have, and we certainly wouldn't have the diagnostics company that we have. I'm gonna grab my water that's in my that dry air. Sorry. So inventorship is really, it's incredible. And so many companies have been started on one single patent that came out of one university, that came out of one lab. And you can see that that could become the seed for a $1 billion pharmaceutical drug. It can become the seed for anything that's in healthcare today. And the changes that have happened because of patents and biotechnology, the number of debilitating diseases that have been tackled in the last few years is all due to inventorship and to patents. And there's no reason why the University of California at Riverside cannot contribute to that. What I really like about patents is that they're not political. And what I mean by that is, I remember the first time I published a paper after I got my PhD, and I was in a department at NYU Medical School, and I had written my paper, and my major professor and I were the authors on the paper. And when I sent it in to be looked at by the powers that be in the department, it came back with 3 names on it, in addition to the 2 that were on there, with people I never met. And so there were people that were part of the system, and we had to put their name on our paper. And I'm like, but they don't even know me. They didn't do anything. This is just our work. So, yeah, Tina, but that's just the way it is. You have to do that. But that's not true about patents. Patents have a legal definition, and that legal and strict definition is really adhered to. If you have not contributed to that as an inventor, you are not an inventor on that patent. And so it's one of those things that I think is very, very pure in the way it still is today. So I'll tell you a little bit about my journey and starting companies and working on patents and what have you. And I like to start a little bit with my background because it's very unusual. And as Catherine said, I'm a first-generation American to go to school. My family came from Greece. My grandparents lived next door, and everyone worked very, very hard. My family were all farmers, every one of them. And my family today is still all farmers, and they're married to farmers. And so when I kind of got into this field, I was like, she's doing really well, but we don't know what Tina does. She does some science stuff. And so it just wasn't the background that my family was used to. And it's been an incredible ride in education. My grandparents actually said to me, well, why are you going to college? You know, we can bring a boy from Greece and you can marry him and just stay here with us. I couldn't think of anything worse. And so at that time, I said, no, I really want to go to school and go away to college. And they kind of shook their heads. My parents were all for it, but my grandparents, they had a little bit of a rough time with sending girls away, And so I said, no, I really want to go. I said, what if my husband dies and I have to get a job? If I'm educated, I can get a better job and support my family. They said, that is really, really thoughtful of you. Yeah, I get that. So I went to college on the premise that I would have a dead husband someday. And so, but whatever works to get you out of town, you go with it. And so here I was at a high school that didn't have calculus, that didn't have physics, that didn't have chemistry. We had auto shop, and we had mechanical drawing, and we certainly had homemaking for the girls. And so when I got to Irvine, needless to say, I was a little behind. And I get there, I was like, you guys had calculus in high school? Really? Wow, I couldn't believe it. And so I had to catch up from the very beginning, and it was difficult. It was not easy, and there were a few times when I just wanted to pull a U-turn and go back and find that boy from Greece and stay there. But, I really stuck through it, and it was just really sheer drive and wanting to do something different and really wanting to make a difference that I stayed with it. And there were many times when I thought about not doing it, actually. And I really wanted to go into science, and everyone said, well, if you're into science, you're pre-med. So, I really? Yeah, you're pre-med. Okay. And so I told everyone I was pre-med and I was going to be a doctor, and they said that was great. Everyone understood that. But one day, I was a dishwasher in one of the labs at Irvine, and I looked over, and there was a postdoc sitting there, and he was pipetting. And I said, what are you doing? He said, I'm pipetting. I said, that looks so fun. He said, really? You think this is fun? I said, yeah. He said, come here. So he comes over, he teaches me how to pipette. The minute I had that pipette man in my hands, that was the end of me. That was the end of med school, and that was the beginning of my scientific career. I still like to pipette. So that was the real turning point for me, and really thought about going into science and not going to medical school. And so at the end of getting my bachelor's degree at Irvine, I thought, well, now what? I'm not going to medical school, and so I can't get a PhD. I'm not smart enough. And so I'm going to just look for a tech job. And so, of course, there's a boyfriend involved, and I came out to Riverside, and I applied for a job, and Jolinda Traw interviewed me and hired me, and I was her lab technician. And I can't tell you what an incredible experience that was, and I did a heck of a lot of pipetting. And I loved it. At the end of a year, she said, you're going to grad school. And I said, okay, I think I'm ready now. And so it was really her encouragement that really drove me, and I don't know if I would have done that if it wasn't for her at that time. So I'm forever indebted to her. And I loved it. I loved it. I was in the lab all the time, anytime I could be. And I still feel that way. And my love for science has certainly not changed. And then once I left Riverside, I went to New York and New York University. I did my postdoc. And then I decided to go into industry. That was a little disappointing for Jolly at the time. She thought I should go into academics, and I said, no, industry's for me. I joined a company in San Diego called Hybertech, and it was incredible. And so I go to Hybertech, and I'm hired as a junior scientist. I'm making $28,000. At that point, that sounded like a lot of money after postdoc money. And living in New York on postdoc money was even better. And so I met with my supervisor, and they gave me my bench, and they taped it off, and they gave me 3 feet, and we had tape every 3 feet. You're a scientist, you're a junior scientist, you get 3 feet, that's it, see you later. And here's your project. He said, what's my project? We said, well, we're having problems with PSA, prostate-specific antigen. We're trying to purify it out of serum, we can't get it purified, we can't get it stable, we can't make the calibrators, we can't make the product for the PSA test, blood test. And so here you go, work on it. And I thought, okay, I'll work on that. So I told my colleagues what I was working on. They go, what project did you get? I said, it's PSA. They said, oh boy, you got that? That's too bad. A lot of us have tried it. We haven't been able to get it to work. I said, really? Why not? Oh, it's really hard. Well, then I realized that everyone had been given the project was either an immunologist or a biologist, but not a biochemist. So knowing how to purify proteins, and I can tell you that Jolinda Trott never let us buy a kit. We did everything from scratch. And so I knew how to purify and stabilize proteins. So I figured it out. A month later, I went to this meeting and I presented it and said, oh, I figured out how to purify PSA. We can make this calibrators now. We can put this product on the market. And they said, you what? I said, no, I got it figured out. And they were like, I can't believe it. And I was like, it wasn't that hard. And they said, you need to go to the patent office. I said, what is that? So we have a lawyer in the building next door, and he's going to write up a patent on your invention. I said, my invention? All I did was purify the protein the way I knew. Oh no, this is an invention. You figured something out that hadn't been done, and for this product. And so there I went, my first job, my first month, to the patent office, and sat and told the lawyer what I had done. He thought I was so clever. And I have my first patent. And to this day, I have that patent hanging in my house. It's in the bathroom. Where else would you put a prostate patent? But it's there, and I'm very, very proud of it. And I got $100 for it, by the way, because, of course, the company owns everything. And at that point, I thought an extra $100 was pretty darn good. So that was my experience in being at a company and being associated with patents and entrepreneurship and how you could see something turn into something. And I then worked on the PSA product, and I can't tell you how incredible it was to see that all of a sudden in a kit, on a pallet, going in a truck and being shipped off as a product. And that is when you really have that reward. And then when you meet people who say, oh, PSA, yeah, I had a PSA test, and that test saved my life. You're like, really? Yeah. That test is still on the market today, unfortunately, because nothing else has come along that's better, but it's still there today. And do you know what it's like when people tell you that your test actually made a difference in their life? So that small invention that I didn't think was much of an invention actually turned out to be something that was pretty incredible and something that I'm really proud of. I didn't do it by myself. There's a lot of us there. We built this product together, and we were a team, and that was what was so incredible about it. But it was the first time I really understood what kind of impact you can have from a lab to a product rolling out the door. After that, I went to a couple other startup companies. All of them were started on patents that were licensed out of universities. Some of those things worked, some of those things didn't. They don't all work. And sometimes it's not that the science doesn't work, it's that science may not work in that environment. It may not be able to be commercialized. It may not make a good product. It may not be what the market needs. And when we're sitting in a lab and we're working on something and we're thinking about an invention, we don't think about it that way. We don't think about, where could this go? And you really need to start to think about that as an inventor. You have to think about it as a product out in the world, because that's the way these companies are started. And you need to think about it all the way. So yes, I've been at companies that didn't work. Yes, I've been at companies that did work. Yes, we licensed technology out of UCSD, Stanford, Scripps Clinic. I've been involved with several. And I'm now at a company where I'm now working on liquid biopsy so that we can have a blood test for NASH, non-alcoholic steatohepatitis, which is fatty liver disease, which is one of the biggest, largest worldwide epidemics that we're about to have. There's no drugs on the market for it today, and we are inventing every day a test for that so that you don't have to get a liver biopsy. So the invention never stops. Starting a company is not easy. Key things are money, are people, and of course the science, and you need all of them. It's not something that's easy to do, and it's not for the meek. But as I said, it's incredibly rewarding. There are so many things you have to think about before you start a biotech company. You have to think about, as I said, what is the market for this? What's currently being done for liver tests? Is there room for my invention in that world? Well, in our case, a liver biopsy is invasive. Doctors don't like to do it. It's expensive. It's very painful. You can get infections. There is a need for a liquid biopsy test, right? And so you need to know that there is a need in the marketplace. You need to know that you can sell that to somebody. Can you sell it to physicians? Can you sell it to medical centers? Can you sell it to hospitals? And if you do, who's going to pay for it? And that's something that none of us learn in school. We don't think about who pays for it. Well, who does pay for it? Insurance companies pay for it. Medicare pays for it. Medi-Cal pays for it. There's all these different government and private entities that pay for our health care. And sometimes they pay for our inventions, and sometimes they don't. What if you invent something that's better than something else, but it's really expensive to do that test? You may not get that on the market, no matter how good it is, because that entity does not want to pay for something that's more expensive than it's out there today. So then you have to prove, yes, but it's better. It may be more expensive. This technology is more expensive. We have to sequence. It's more expensive. That's more expensive than running an immuno, test. And so you have to think of all these things. You have to think of the competition. There's people out there trying to do what you're trying to do every day. And you can never think whatever you have is best. Someone is going to try to invent something better than you. You have to convince venture capitalists who give you money to start these companies that you understand what you're doing, that you understand that you know how to run a company, that you know how to take that science and commercialize it and turn it into something. You have to show them a business plan. You have to show them a financial plan. And day one, they're asking you, when are you going to be profitable and how much money are you going to make? And you're sitting there going, I haven't even run one experiment. But you have to be able to answer those questions. Yes, will it change? Yes. Is your original business plan the one you end up with? No. But you have to start with all those components in place. So if you think about starting a company, all those pieces are really important. But what's at the core? The invention, the patent. It all comes back to that. I feel very fortunate to be part of biotech. I look what's happened in the last few years. We now have drugs on the market for HIV that we didn't have several years ago. And now someone who's 20 years old who is diagnosed with HIV can have a very normal, long life. Things like hepatitis C were deadly diseases, and now we have drugs on the market that really cure things that are out there. Childhood leukemia was not what it was and what it is today. Most children are cured because of drugs that have been developed, that started in biotech, that started as inventions, that started as patents in universities. So we have the opportunity at this level to really make a difference in the world and in healthcare. And if you think about it in that way, that's really, really powerful. And there aren't too many people that go home from their job every day and can say, I'm trying to do this because I want to make this a better world. I want to be able to cure a child that has something where there isn't something today. Do most companies fail when they're small? Yeah. Do most drugs make it to the market? No. Do most companies go through times when they can't make payroll and you don't get a paycheck? You bet. But you know what? When you know what's at the end of that, that's a driver and nothing gets in your way. And so again, I'm really proud to be here today. I'm proud to be part of this incredible program that you've started on inventorship. I hope I've inspired one person that has a patent or thinking about having a patent or thinking about starting a company to do something and do it big, because there's nothing like it. And I recognize and honor you for your excellence. And I thank you for helping the world be a better place. And thank you to UC Riverside and Catherine and the whole team here for inviting me to be part of it today. Thanks.
Wow. That's all I can say is what a journey. What a journey. Thank you for sharing your experiences and inspirational words with the audience today, Tina. Just as a token of our appreciation, we just wanted to get you a little something. All right, so Tina had a lot of great things to say, and really, why are we here today? What are we celebrating? What are we recognizing? We are recognizing, I'm trying to fix the clicker here. So we're recognizing innovation. We're recognizing patenting. We're recognizing commercialization and entrepreneurship. So if we can put up the slides, that we can start moving forward with the slide deck. Thank you. So as Tina mentioned, inventorship patents, it's not something that's normally recognized, right? So even in the academic community, innovation, patenting, commercialization, entrepreneurship, it's not a measure of recognition during merit reviews for faculty for tenure-track faculty. Issued patents are not, and issued patents are not trivial, right? So it's not, there's a lot of work that goes into the research that goes into getting a patent, right? So it's not just time, it's also money, from idea conception to commercialization. In fact, many years in the making. So most of the patents that we're recognizing today, those were disclosed to the Patent Office probably 5 to 7 years ago, right? So just think about that, right? And so that means they had to have conceived the invention 2 or 3 years before that. Right, and so it's a long process, and there's a lot of work that needs to go into it. But really, the ultimate goal, as Tina mentioned, is not just getting that piece of paper and not getting that patent. It's really to translate that research and commercializing technologies for societal impact. That's what we hope to accomplish. So, and I think what is that you're holding in your hand there, Tina? Is that a pipette? So I would be remiss if I first didn't talk about the Office of Technology Partnerships, led by Associate Vice Chancellor Rosabella Ochoa, and she reports to Michael Pisani. So there are 3 primary functions within the Office of Technology Partnerships: corporate and strategic partnerships, technology commercialization, and innovation and entrepreneurship. So our mission is to facilitate the development and commercialization of ideas emanating from UCR and the community for the benefit of society, right? So really it's that impact. It's not just for research's sake, but what are we doing? So right now I'd like to focus on the technology commercialization piece. You'll hear more about the other portions of the OTP from Larry Morgan, Director of EPIC, later this afternoon. So here, I know it's a little bit hard to see, but really it just kind of shows you a little bit of the activity that's going on at the university, right? So from invention disclosures that we've been receiving, the last 2 years we're in the 70s. It's significantly more than what we've had in the past. This past year, provisional patent applications that we filed, and we've had 27 issued patents this year, and I think that's the most. As you can see, the trend, which is the gray number, is the trend is ticking upwards. So the number of our inventions that are licensed, right? So if you look at our overall portfolio, I think almost 30% of our invention portfolio, IP portfolio, is licensed. Over 50% of our issued patents are licensed. So there's a lot of activity going on within our tech transfer community here on campus. So what does that mean? So we are doing and executing a lot of license agreements. So last year we had 6 license agreements, 4 to startup companies, right? So our royalty revenue last year was almost $5.8 million here at the university. So and as you can see the trend, that is continuing and steadily growing as well. So of those license agreements, here's some recent startups that have actually taken technologies and made that endeavor or started that endeavor for commercialization. And you'll hear from two of the companies actually this afternoon. So that's MG Fuels out of CSERT, and then Sensorigen, which is a faculty affiliated startup company here. So you'll learn about both of those here this afternoon. So now with that background, let's get into the patent award ceremony. Like I mentioned, in fiscal year 2017, that's between July 1st, 2016 and June 30th of 2017, UCR had 27 issued patents by the U.S. Patent and Trademark Office. So first, I wanted to recognize those issued patents where the inventors could not be here today. So I'll go over these pretty quickly. I'm not going to read them in your programs. They're listed in your programs and you can follow along. So I just wanted to highlight some of the inventors and faculty and students that are part of those. So first, Michael Peron, right? So next is a former UCR faculty, Gere Bertrand, who's now at UCSD, with some postdocs and staff scientists. Philippe Rollhausen and Carolyn Roper have issued patent this year. So David Kisailus and former students. So what you'll see in the bottom right-hand corner, I put a little a handshake icon, and really that's to identify those patents that we have had a license agreement in with the last fiscal year. So what you'll notice about David, he's actually had 4 issued patents last year. That's the most out of any faculty or any inventor that we had at UC Riverside. And many of those are with his students and with his postdocs and with his team. So he's had 4 of those. Xiaowei Ding and his collaborators. So those are patents that have issued. So 2 of them that have issued for Xiaowei. And then this one here is Dmitry Muranyi, and I was told that he snuck in somewhere. Is he in the audience? All right, Demetrius, if you want to come up, so we had you listed as the not here category, so we weren't prepared, but we'll invite you up here and get this moving forward as we recognize inventors that are here. So we put together a little plaque, a little memento for our inventors, which is to highlight and recognize the award ceremony, the inventor, and then the patent number. So this is something that you can take back, put on your desk, show off to your friends and colleagues. So congratulations. So next is Giorgio Speed and a former postdoc of his. Yingbo Hua and Ping Liang. So they were not able to attend today. And lastly, Shun Yan and a former student of Yushan's. So unfortunately they weren't able to attend. They weren't able to join in the festivities. But right now we'd like to move forward on recognizing inventors that are here. And I think hopefully most of them are here. So what I'm going to do is try to follow through these through the patent number. So if you want to follow through, so I'll call you by your name, and if you hear your name being called, so please come on up. But before I do that, I wanted to invite Rosabelle up to help with pictures and capturing this moment for the inventors. So first is Yadong Ying and former student Zenda Liu. The patent is direct assembly of hydrophobic nanoparticles to multifunction structures. So is Yadong in? I didn't think he was here yet. So, all right. Is Tomas Yogum here? So he's not here either. And so Tomas and former students Melinda Rodriguez Salas and Colleen Noth for 2 patents, molecules that induce disease resistance and improve growth in plants. So next is Cengiz Ozkan, Miri Ozkan, and former student Jennifer Reiber Kyle for centimeter scale high resolution metrology of entire chemical vapor deposition growth graphene sheets. Congratulations. Is Bhanu? Bhanu, come on up, Bhanu, and former student Meron Kafai for Dynamic Bayesian Networks for Vehicle Classification in Video. So congratulations. Next is Anand Ray and former students Sean Boyle and Stephanie Turner for 2 patents, methods for assessing repellent quality of organic materials and methods and compositions for repelling arthropods, which is licensed to one of the companies that you'll hear from, Sensorigen, and insect repellent and attractants. Thank you very much, Anand. Congratulations. Arun Raju here. Arun? So Arun Raju, Chang Sung Park, and the late Joseph Norbeck, they were issued a patent for method to produce methane-rich fuel gas from carbonaceous feedstocks using a steam hydrification reactor and a water gas shift reactor. Congratulations. Guillermo, is Guillermo here? There's Guillermo. Guillermo Aguilar Mendoza, Javier Garay, and collaborator Santiago Camacho Lopez for method of making waveguide-like structures. Congratulations. Next up is Carol Lovett. Do I see Carol in the audience? All right, so Carol's not here yet. So Carol, for use of 9-beta-D-adenosine to increase crop production. So what you'll see for this one is, you'll hear about it a little later in some of the royalty revenues, but it is licensed to a company, actually a small company was acquired by a larger company, and now they've actually got products on the market helping growers and farmers. So No-sang Myung, I know he's here, I've seen him. So No-sang. No-sang and former student Milo Zhang, ultra-sensitive gas sensors based on tellurium single-walled carbon nanotube hybrid nanostructures. Congratulations. Is Jason Cheng here? Jason? So it's Quan Jason Cheng and former postdoc Ji Chen Duan and student Matthew Linman, ultra-thin calcinated films on a gold surface for highly effective laser desorption ionization of biomolecules. Did Alexander Balandin, did he make it in yet? They're missing their moment in the spotlight. So Alexander Balandin, graphene-based gas and biosensor with high sensitivity and selectivity. So lastly is Wenbo Ma. I know she's here. Wenbo Ma and Georgios Vadilakis, identification of secreted proteins as detection markers for citrus disease. So I'm going to ask, thank you very much, Rosabelle. So I'm going to ask Wenbo to stay up for a moment because she is the next speaker. But before we do, please join me in congratulating all of the inventors that are here and not here for their award and for their recognition for issued patents here in fiscal year 2017. So I don't know if you noticed it, but one thing that I noticed was most of the actual people that are here are the faculty inventors. And yes, students graduate and postdocs move on. But as you sit in the audience, I really want to encourage you to invite current and former students, postdocs, and colleagues to participate in the future, as they are also integral to the innovation lifecycle, right? So it's not just the faculty and inventors, it's also the team that you have around you. So like I said, next up, I'd like to introduce Wenbo Ma, professor of plant pathology here at UC Riverside and co-inventor of a patent that can have a direct impact close to home. So Wenbo and Georgios have developed a technology that can help detect a particular citrus disease, HLB, that has decimated the Florida citrus industry and is threatening California's. So I'll let Wenbo fill in the rest of the details. Wenbo, thank you very much.
I would like to really thank Brian and Larry and Mike and everybody in the Office of Research and APAC for giving me this great opportunity to talk about our patent. And it's really, I'm not used to this kind of audience, so my presentation will be quite research-oriented, but hopefully this is big enough for you to see. What our labs are, me and my research collaborator, Giorgio Speed, who is also a professor in the Department of Microbiology and Plant Pathology, what we have been working on is this very severe citrus disease called Huanglongbing. It's a Chinese word. It translates into English as yellow shoot disease, and that's one of the symptoms of this disease. But first of all, I would like to say that citrus production is very important to the U.S., and this is citrus producing map, and you will see the darker color are the main citrus producing areas, and the U.S. is the third, just after Brazil and China, and a lot of it is produced in California. But this industry is severely threatened by this one single disease called HLB or Huanglongbing, and here you can see some of the disease symptoms, and obviously the fruits that are produced from infected trees is not marketable at all, and that's very important for California because we are the main producers of table fruits. During the past 10 years, this disease has caused a really enormous damage to the Florida industry. And this is the same orchard that was pictured just 1 year and 1.5 years apart. And you can see from a healthy looking orchard and turn into an orchard filled with dead trees. And there's nothing we could do about this disease. So I hope you can see, and this is very dramatic figure, and this is a citrus production in the last 10 years in Florida, and you can see the reduction. This is 70% reduction. This is really huge damage. And this is another way of looking at it. That's every year in Florida only, the citrus industry lose almost $1 billion cash. So this is really, you may not be aware, but this is a huge damage. And the problem of all that is that there's no cure. So once the trees are infected, there's nothing anybody can do except for watching them to die. So eventually, you will see orchards like these. The farmers can only chop them down, and then when you regrow new seedlings, they will be infected again. So the cure is one of the problems, and the other problem is diagnosis, obviously. So I'll talk about our patent later on. And I found this just came out recently. I found this very interesting. This year is the first time in history that the California citrus production surpasses Florida citrus production. And that's only because Florida citrus is damaged so badly by HLB. But we shouldn't be happy because HLB is here too. So California, let me show you this. This is the title of a news article in the PE, and that was published in July 26th. So that's about a month and a half ago. That was a tree was identified to be HLB infected in Riverside, close to campus. So actually, UCR now is a quarantined area by USDA. And is it really important? Of course, because Riverside, we have the first citrus trees of all the United States. And if you can see that historical picture there, that's actually Mission Inn, and the gentleman in the middle who was replanting one of the two parent citrus trees is President Roosevelt. So this Riverside really has a very significant long history of citrus production, and one of those two trees is still alive in our citrus historical park. But we may lose all that if we don't cure this disease. As I said, there's no cure. So very simple introduction of the culprit is caused by a bacterial pathogen called called Liberobacter, Candidatus liberobacter. In the US, is a species called Liberobacter asiaticus, so we call it CELAS. And this bacteria has an insect vector, so it's either in the insects or in the citrus trees. And the insect, when they feed on a infected tree, they'll pick up the bacteria, and then when they feed on a healthy tree, they'll pass that bacteria to the healthy tree. So if we have infected trees in the field and we don't know, and this insect will spread the disease out. So, and without any curative methods. So all we can do is to remove the infected trees so that they won't serve as source for further infection. And that really makes the diagnosis very, very important, because these diseases are really hard to, this particular disease is very hard to be diagnosed because these bacteria are hiding in the phloem. So this is the vascular system of trees. And they have very active material transportation in there. But this also gives us opportunity because maybe we can detect some things that are circulating and then spread out in the system. So that's the basis of our patent. So, oh, I forgot I have this slide, and this is just to show you the one on the right with these plates with holes, and these are the phloem system. And you can see that because it's not really a tube, it has this septa, and the bacteria cannot move very fast in there, or many times they don't even move. So if you imagine this big tree, and this infection may only happen in this a couple of branches, and the bacteria will stay in that branch. But if you take a sample from another branch that without the bacteria, then you wouldn't think this tree is infected, whereas it's already infected. So what our approach is to identify a protein biomarker, and these proteins are small enough so they can actually go through those holes that in the phloem system, and then you would be able to detect it from in a branch that doesn't have the pathogen. Okay, so that's really the whole basis of our patent, and we found a very good biomarker, and it's small enough, and it's secreted by the bacteria which are in the phloem, and once the proteins are secreted out, they are actually travel and distribute in the other part of the tree, and that really enhances our chance of getting a sample of this tree and then get a positive reaction by using an antibody-based detection. So this an antibody we can generate from animal models, and then these kind of high affinity binding to the biomarker, finding them, and we can see that reaction if there's binding going on. And that would give us a positive diagnosis. And there's a diagram showing there, and what I really want to emphasize, the advantage of this patent is that these proteins can move beyond where, and be present beyond where the pathogen cells are, so that the PCR or DNA-based detection would come up negative if you didn't really take that branch containing the bacteria, but our method will become positive because the protein can move faster and spread wider compared to the pathogen. So, so we do have some very nice results, and this is just one of the evaluation assays that we did. We took 108 trees from Texas. Texas has about 30% infection for this disease, and then we can compare that to the only standard diagnosis, which is PCR-based, DNA-based detection. And what you can see there is that for the PCR positives, we also have a very high positive rate. It's not 100%, so we're still improving, but the vast majority is that we also got positive. But from the negative trees that PCR came out negative, we can diagnose more potential positives from these would be false negative trees. So I'm not going through the details, but we do have evidence showing that our method can behave better in certain cases than the nucleic acid-based detection. And then eventually what we want is to have a kit, and it's called ELISA kit, and using antibodies, and we can provide this to the customers, some reagents and some antibodies, and then these reactions can occur on these 96 well plates. So these are very small plastic plates with 96 wells, and then we can, in one run, we can test 96 different samples. So this is rather fast and cheap and high throughput. And so this is the first step, and now we already have one in place. And the second step is that we can improve and having more sensitive ELISA assay by introducing more antibodies in there. And the third step is that we could further modify this test by producing like pregnancy paper type test that people can bring to the field and directly test their tree. So, my collaborator, Giorgio Speed, he is an expert in citrus diagnosis, and he developed assays for other diseases too. And so I put the title is, there are many other diseases that damage or threaten the citrus industry in addition to HLB, and many of them are viral diseases, and Giorgio is an expert in that. And all these diseases also cause potential huge damage to the citrus industry. So I'm not going through the list. I'm just saying that Giorgio has developed this multiplex test. So using one single test, he can detect 6 different diseases, and another single test, he can detect 14 different diseases. So from 2 tests, he is able to call positive or negative for 20 different diseases. And this is really very powerful and also very high throughput. So with that, I wanted to conclude and thank all the people in different departments at UCR, and especially Brian and Joyce for the IP, and James for industry relationship, and lastly but not least, Larry and Ken for really helping me to really grow into a potential candidate entrepreneur, and I'm learning a lot. It's a pretty steep learning curve, and of course my collaborator Georgios, and also my postdoc Agustina Di Francisco, and Deborah Pagliaccia there, and also PhD student Kelly Clark, and this research has been funded by USDA and the Citrus Research Board, which is the California Citrus Commodity, and also by UCR Proof of Concept grants. Thank you very much.
All right, so thank you very much, Wenbo, and I hope that your early HLB detection kit can be ready for the market soon. And I think working with Larry and working with EPIC, hopefully that will come to fruition. So next, I would like to introduce Larry Morgan, Director of EPIC, to talk about the amazing progress that the team has been able to accomplish in just one short year. So Larry?
Good afternoon, ladies and gentlemen. This is your pilot speaking. Welcome aboard the 405 Epic flight from IP to commercialization. We also welcome aboard our special guest speakers, known to many of you as Tina, Catherine, Wenbo, Charles, and Thomas, and our patent award winners, many of they are. We expect this segment to last only about 10 minutes. We have a terrific crew of EIRs on board to be of service to all of the entrepreneurs, so I encourage you to sit back and enjoy the journey. I can tell you that with every new startup, you can expect significant turbulence along the way. But if you will fasten your seatbelts and put your seats in the full and upright position, and follow the instructions of your technology partnership team members, things will be fine. Now, please turn off your cell phones and all electronic equipment. Do not put them in airplane or silent mode. Just pay attention to the screen in front of you and enjoy your trip. We should have you to your next segment and on your way to the next speaker in less than 10 minutes. So I hope this informative 600 seconds, you will come to visit us again as your commercialization needs require assistance. Thank you again for flying Epic, and have a great day. Good afternoon. Thank you so much for coming. It's truly a pleasure to celebrate our first anniversary here. We have had a terrific year, and as I mentioned to you in this very room a year ago, our job was to help build the ecosystem for the entrepreneurial community in Riverside County, and to be a leader in that. And you know, they say that if you don't know where you're going, any road will get you there. And that is so true. And unfortunately, when you look out onto the horizon as entrepreneurs, as Tina pointed out, there are a gazillion things to think about. And so the ability to choose the right path is so critical to your success. Now, how can we help? What is it that we can do? Well, it all begins with a conversation. If we understand what it is you want, where you're going, we can help to guide you there. And then there's a variety of pathways you can go, whether it's the commercialization route and working with industrial partners, whether it's working in the patent and licensing office, or whether you want to commercialize your idea and indeed become an entrepreneur and start a business. All right? We are here to help you with all those things. All right? I'm going to speak to the things that are on the far right, which deal with I-Corps and training and seminars and education. That's the area where Epic focuses first. We bring you right through a whole series of training classes that are free to help you to validate your market and determine if indeed there's something there. There is a there. EPIC, as you know, stands for Entrepreneurial Proof of Concept Innovation Center. And our mission is real simple. We are here to educate, to coach, and to help you fund your idea. You're all familiar with this chart. You've seen this many times before. It is a universal challenge. It is exactly what Tina spoke about. People on the far left where you start have no money, but they have a great idea, and they're trying to figure out how they can take that, develop a prototype, and then try and cross that valley of death. And that's where you need the most help. Most of you in this room are very bright. You've got terrific ideas, as witnessed by the presentations that were just given by Brian. You get to that prototype and figuring out how to cross across without falling into the valley of death where all the products end up and coming out the other side. This is where EPIC comes in. Our job is to help. Our job is to coach and get you across so that your product is indeed a success. You can become a commercial success. You can be the next Tina Nova standing up here next year or 2 years from now presenting to another group. What happens is there are a variety of steps, and Tina brought those to light, all right? Whether you're trying to form a team or validate your product or trying to figure out how you're going to develop your business plan, all of those different steps have needs, and many times you can use some support. The team that we have assembled is here to help you to do that every step of the way. Number two, in order for you to commercialize your product, there is a path that is tried and true to help you to acquire money. You heard Tina mention, you need a product, you need people, and you need money. All right? You guys all have the product, all right? We can help you to build the team, and we can help you to find the money. So that path is simple. You come with your idea, we put you through some coaching and some training. You end up in the rinse, wash, repeat cycle as you improve your story, and hopefully out the other end, you come and you are then prepared to pitch to a venture capital firm for money. Or maybe your objective is to pitch to a commercial entity or an industry sponsor to get them to sponsor your research. Or maybe your objective is just to license your technology so that someone else can create a company around it. All right? We're here to help you through that entire process. I have a great team of people. We have 8 entrepreneurs in residence that are available to work with you. We come with a variety of backgrounds and educations, a lot of different specialties and subject matter expertise, and we come from all different industries. So I would encourage you to take advantage of that. So what's next for us? We've had a terrific year, but what's next for us? We would like very much to close our first Highlander Venture Fund deal. All right, the Highlander Venture Fund is a $10 million venture capital firm that was created to fund seed capital, qualified opportunities for seed capital. All right, we closed our first round in June. We're looking very closely at trying to get our first deal. Number 2, we really want to serve as a resource for SBIRs. That's free money. It's non-dilutive funding. You can't beat that. If we can help you to figure out how to traverse that whole process quickly and successfully and raise the percentage odds of you getting that money, that's a huge success. And then lastly, all right, we have an I-Corps program that we've been doing for the last year. We've delivered 7 cohorts in every major city in the county. We now have our phase 2 of that ready to go. So phase 1 has a start on Tuesday next week, and we're looking forward to delivering phase 2 in about a month. So I would encourage you folks to think about signing up for I-Corps if you'd like some more education on validation and testing your market. Our objective is real simple: to become the resource, the go-to resource for the entrepreneurial ecosystem here in Riverside. Could not be any simpler. Office of Technology Partnerships, of which we're a part of, and you heard Brian mention earlier, has had an outstanding year. Under Roosevelt's leadership and guidance, we have executed over $10 million in corporate-sponsored research projects. We have gotten funds from the state for $2.2 million. We've gotten a couple of EDA grants for $500,000, and we were just recognized as an I-Corps certified location, and that gave us another $500,000. We've launched the Highlander Fund for $10 million. We've launched the Creator Lab, which is a makerspace in the library. It's available to students and professors. And last but not least, RED and MolMed, the Research and Economic Development Group and the MolMed Translational Medicine Group, provide proof of concept grants, again, to qualified opportunities. And we've done 5 of them this year, between $30,000 and $50,000 each. The solicitation for the next round has already been put out, and that'll be fulfilled sometime early November. So I would encourage you, if you have an idea that you'd like to try and get some free money for, sign up for that. Last but not least, it was when I stood up here, I made you guys a whole bunch of promises. I told you we're going to do this, we're going to do that, and everybody got all excited, and everybody's sitting there going, yeah, show me. All right? Over the course of the last year, we've enjoyed a lot of success. And I'm not here to brag, but we have gotten $3.2 million in grants. We had 11 EIRs and mentors that work with the teams, whether it's in the classroom or in one-on-one sessions. And then over 160 teams have taken advantage of the resources that we provide to help them develop their business plans. Underneath the launch startups, 46 teams have gone through Mark Leibowitz's training program, and we have offered 7 cohorts of what we call Startup for Integrators. Quickly, moving along, MolMed, we launched the grants, as I told you. We gave 3 MolMed grants. And then on the training side for Excite, we've worked with Excite, our partner, which is the accelerator or the incubator that's across the street, where we've provided some training and some seminars and participated in a lot of the different seminars for Startup Week. Last but not least, the Highlander Fund. $10 million, qualified opportunities, seed capital. We have already offered 2 term sheets to 2 different teams, and we're looking very anxiously to close our first deal. With that, I want to thank you so much for your time and attention, also for your support over the last year, and I'm happy to answer any questions. Thank you. Yes, sir. Back to the lab. I mean, you really do have to have a minimum viable product in order to go to the market. The EPIC program will help you to frame where you think you're going to go. They will coach you and guide you as to what the next step should be. All right, and then if you're ready with your product, they will help you to prepare your pitch deck so that you can go pitch for money. But chances are good that if you don't have a product that you think you can go to market with, it's going to be hard to obtain some seed capital. Yep. Well, we survived last year, so I would say the EPIC program's not going away. You haven't outgrown it. You just come back when you're ready. If you remember the rinse and repeat cycle that I showed, people fall into that all the time. They think they're ready, they haven't got their story straight, or their product's not ready, or they've gotten some other advice. And so just keep coming back. We'll work through with you, and we'll create some milestones that are accomplishable and help you to understand what the next steps are to be successful. It doesn't mean that we're always right or that your product will be a success, but we will give you the best guidance we've got. You're welcome. Anything else? Yes, sir. Yes, it's non-dilutive funding. It's a grant, right? It's a gift. It comes with some hooks, all right? You have to go through some training. You have to create milestones. Those get measured. You meet with your mentor regularly, all right? So it's based on accomplishing milestones. It's not just we give you 50 grand and say good luck. All right? Thank you. And if you go to our website, you can see the applications right on there. Terrific. Anything else? Thank you. Okay. If I'm correct, good. It gives me great pleasure to introduce our next speaker, Charles Kai. Charles is currently an assistant research engineer at CSERT and an assistant adjunct professor of chemical and environmental engineering here at UC Riverside. His entrepreneurial endeavors have led him to be the co-founder and CTO of MG Fuels, who licensed UCR intellectual property, and most recently, Charles was named Forbes 30 under 30 in the energy sector. Please help me welcome Charles Kai.
Thank you, everyone. Good evening. Thank you, Larry. Thank you, Brian. It's an honor to be here. I wanted to talk a little bit about my background, as well as how I got to where I am now, and sort of the learning process that I've accomplished in developing technologies in the bioenergy space. And so, so before we move on to the main presentation, I thought I'd give a little bit about background about where I started. This is for maybe the younger people in the audience. I graduated from UC Davis with a biochemical engineering degree, and after that I thought to myself, hey, I would really want to work for a nice company, and biotech was booming, so I went to the Bay Area, and that was where I met Professor Jay Kiesling, and he introduced me to his startup, Amyris, that is now a very large company, and has spawned several incubators since then, and they were really working on doing bioengineering of Saccharomyces cerevisiae, which is yeast, to producing something called farnesene, which is a derivative of squalane. And they were doing it for bioenergy applications. I was really excited about bioenergy, so I went to the company expecting to work on bioenergy. However, with many startups, as you know, the original goal of your product and your technology is never really the final outcome, and that's because it is manipulated and changed and shifted based on business and time outcomes and financial outcomes. And so as I started working in the company, I realized actually this product is way too expensive. We were actually producing farnesene at $50 a gallon, and there's no way we can sell that as fuel. However, it's nice because it's a biological compound, and it's from biotechnology, and so we could sell it for a higher value, such as for lubricants and other things. And so in the company, I sort of took a different role away from bioenergy and sort of moved into application development and assay development. And in there, I noticed that in order to really excel in an industry, you really have to be very application focused. You have to develop things that have sort of an end product, either at the end of a project or at the end of a timeline, in order to deliver a product to market. And that is entirely dependent on the foundational technologies or the platforms in which they sit on. And so I thought to myself, well, I don't really know too much at that time. I was just an undergrad. I just graduated, and I developed some cool things for Amyris. And Jay came up to me, and he's like, "How would you like to go to grad school?" And I thought, wow, that was a really good opportunity to work in Berkeley and to be part of this lab. But then I realized, this is deviating from my original spirit, where when I graduated at UC Davis, I really felt a passion in bioenergy. And so this is where I made the most difficult decision in my life. I rejected a Berkeley graduate program and basically looked elsewhere. And one of the names that popped up was Charles Wyman. And he is a professor and chair here at UCR. And it was his research that really took my eye. And so I was basically struck with the decades of research he has put forth in moving forward with bioenergy, and I wanted to learn more. And so I applied to UCR's graduate program, and I came in and was really excited to meet Charlie, and he was really excited to welcome me into the lab, except there was one caveat. There's no funding. And so I was like, wow, I came into grad school, I applied, I made this leap of faith, and now there's no funding. What do I do? And, in the spirit of things, Charlie is an inventor. He is the co-founder of several companies. And he said, well, think of an idea. And I said, well, I don't have any ideas because I just got here. And so what was interesting was that because there was no funding, it actually forced me to leave. And so I actually had to go back to Amyris, and I would say I came back crawling to Amyris, and they were all laughing at me. They're like, "Hey, welcome back, what happened to you?" That was a really short graduate program. And so actually within one summer, I actually left and came back to Amyris because I needed some way of affording my rent. And so, and this was because I didn't have a project. It wasn't, I didn't have any funding at the time, but I was very driven. And so now the second time around, I was like, I really want to develop something. So in the off time that I was working for Amyris again, for the summer, I was looking at things that we can do in the bioenergy space to really advance the field. And where it occurred to me was that there was a lot of research in biotechnology downstream. There's a lot of research in catalysis and material design downstream. It was all really exciting science, publishing really well, but all of it hinged upon solving the upstream, which was the really simple, really dirty, really unelegant process of converting essentially plant waste into something that you can use, chemical precursors or biochemical precursors that you can then convert into really fancy stuff or fuels. And so I thought to myself, well, why hasn't that many people looked into it? Well, it's because, as we all know, plants are very resilient, right? I mean, the tree trunk is made for the tree to survive for hundreds of years, and so it's really difficult to break down. And in fact, if you can't solve the energy burden of breaking down plant matter first, how are you going to make an energy product? And so I thought to myself, well, this is really the key. The Earth takes 23 million years, 17 to 23 million years to really make the oil that we drill out of the ground and we use in our cars. And so how is it that we can accelerate this chemistry such that it's cheap enough, low energy enough, that we can produce a viable precursor so that all the downstream biotechnology and all the downstream chemical catalysis and material processes can utilize? And I thought to myself, well, it has to be really simple. Right? And this is a little bit comforting to me because I was like, well, if it has to be really simple, then I don't really have to, know too much. I'm ripe for the picking. And so then I said, okay, well, the solution must lie within, a very basic, deconstruction chemistry from moving from, what essentially is wood fiber, into a liquid fuel. And so I surveyed the range of solvents, chemical solvents, and I knew that, water couldn't cut it. wood already has water, so there must be something else I need to put in there in order to accelerate this breakdown. And I looked at many solvents, I looked at off-the-shelf solvents, and I realized, hey, there's people in this field already doing this research, and they're using very exotic solvents, very expensive. And that's why there hasn't been very many companies that have been successful. In fact, if I remember correctly, even to date, there's not a single successful biofuel company that is converting biomass into biofuel. Not a single gallon has been made profitable. And the reason for that is because the deconstruction of plant biomass is just way too challenging. And so where I came in was, I was like, okay, well, I have to look for a solvent that is inexpensive, that can be manufactured, and if it's already being manufactured, is even better. And I came up with that solvent, and it's called tetrahydrofuran, and it's called THF. And some of you may know it in assay chemistry, some of you may know it in biotechnology. And it's a very nice polar product solvent that actually is derived from biomass. You can actually make tetrahydrofuran from plants. And I thought, well, that's great, because if I lose some in my process, I can make it back. And so with that, I essentially took tetrahydrofuran and used it in a way that is very unconventional. Because in most separation chemistry and most separation process, you want something to be easy to separate. And what better thing to separate if it's completely immiscible? Right? And so most separation processes in biomass deconstruction use biphasic systems. And so THF was largely ignored because it was miscible with water. It made one phase. And in fact, it has a very unique sort of phase interaction throughout the temperature spectrum that gave it some confusing properties. And so people tended to avoid it and didn't really use it. But I thought to myself, well, single phase is pretty easy, right? I mean, we can load up the reactor with as much wood as we want. We don't have to care about another phase. And apparently, this has really good solvent properties. Let's try it. And it was just one of those things where it's just, let's try it. I know the industry is ignoring it. I know academia is ignoring it. But I just want to try it and see what it does in a single phase system. And guess what?